Hello, everyone, and Slamet Datam. A very warm welcome back to the lab for today's explainer. I am absolutely thrilled to have you here with us. Today, we're diving straight into something incredible, architecting unstoppable agility and how to systematically scale our digital ecosystems. And, we couldn't decode this without our lead expert of idea mechanics standing by on the virtual floor. There he is, the navigator, looking extremely sharp today in that signature red shirt, the glasses, and of course, these silver accented hair. As our resident innovation catalyst, he's going to guide us right through bridging that huge gap between abstract ideas and practical, real-world execution. Okay, let's jump right in. The absolute foundation of everything we do here is TRIZ. It stands for the Theory of Inventive Problem Solving. Now, what is that exactly? Well, it's a highly repeatable architectural discipline and a systematic innovation methodology. You might be wondering, why does this actually matter? Because the navigator and I are on a massive mission here. We want to prove to you that innovation is absolutely not some random lightning bolt eureka moment that only a lucky few get to experience. No way. It's a highly structured, repeatable process. It's all about systematically solving complex technical contradictions without blindly relying on the old trial and error approach. If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team.
And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next.
Welcome back. So let's look at the stark contrast between how we used to build systems and how we absolutely must build them today. The old way, that exhausting trial and error trap, it basically forces us to guess our maximum necessary capacity up front. And what happens? We end up locking our infrastructure into these incredibly rigid, static designs. Actually, some studies show that up to 70% of traditional IT infrastructure just sits there, idle, literally waiting for a what-if scenario. It's exhausting, and let's be real, it's incredibly expensive. It's like building a rigid stone wall just hoping it's strong enough to stop a massive storm. When the conditions inevitably change, that wall just breaks. But the TRIZ way? The path of systematic discovery is completely different. It replaces all those rigid constraints with fluid, architectural discipline. We are moving far away from static, quote-unquote, dumb architectures towards systems that intelligently and dynamically respond to the world around them. And that brings us to the absolute star of today's explainer, TRIZ Principle 15. We call it dynamics. The official definition here is pretty profound. It's all about designing systems and objects to be adaptable, flexible, and capable of changing their characteristics to achieve optimal performance under varying conditions. So what does this actually mean for us? The crucial point here is that true digital agility isn't about perfectly predicting the future. Honestly, who can do that? It's about engineering a system that doesn't even need the future to be perfectly predictable. It simply adapts on its own. Look at how the navigator breaks this down for us. Notice the core elements he's pointing out right now. First, we introduce variability and adaptability. We allow a system to find its optimal operating condition completely on the fly, and we increase the degrees of free motion. By introducing this level of dynamic adaptability, we directly resolve the contradiction of being stuck in a fixed state. You no longer have to choose between two really bad options because the system just shifts to accommodate exactly what is needed in that exact fraction of a second. It's brilliant. Let's see how this actually translates into real-world IT infrastructure. We're looking at a comparison here between fixed provisioning and massive traffic surges. Now, this is the absolute classic technical contradiction of static servers. Think about it. If you use a static approach and provision way too much server capacity, you waste a massive amount of money on underutilization. Your servers are just sitting there in the dark, basically burning your budget. But flip it around. If you provision too little, trying to save a bit of money, well, you practically guarantee a catastrophic system crash right in the middle of a massive holiday sales surge. So you're totally trapped. You're trapped between wasting your budget and losing your revenue. So how do we systematically solve this nightmare? Watch the navigator here as he maps out the dynamic resource allocation of modern platforms like AWS and Azure. This, my friends, is cloud elasticity in action. We are applying Principle 15 by abandoning static servers entirely. When an e-commerce site gets a sudden surge of traffic, the system detects that load increase automatically. It instantly spins up additional server instances. It handles the high traffic flawlessly, without breaking a sweat. And then, honestly, this is the beautiful part. Once the traffic subsides, it terminates those instances to completely optimize your costs. Your infrastructure literally breathes and expands in real time. It is pure architectural dynamics at work. But hey, let's not just stop at digital infrastructure. Let's shift our focus over to human workflows for a minute, because Principle 15 applies exactly the same way to how we organize our minds and our development teams, too. We are contrasting the old waterfall methodology with the agile methodology. The old waterfall model, it's just like that static server we talked about. It's rigid, it's linear, and it is highly resistant to change. It forces teams into these incredibly inflexible plans for a single, massive project. And, well, we all know how much developers love fixed requirements that suddenly change on launch day, right? But software requirements are rarely static. They are incredibly fluid. Agile methodology, on the other hand, perfectly embodies Principle 15. It's fluid, it's iterative, and it completely embraces evolving requirements through continuous user feedback loops. Let's break down exactly how frameworks like Scrum and Kanban apply this dynamic principle to human teams. Instead of one massive, unchangeable, monolithic project, we execute short development cycles, or sprints. During and after these sprints, we gather continuous stakeholder feedback. Then we take that intelligence and incorporate it instantly into the very next iteration. This allows us to constantly evolve and improve the product. By doing things this way, we create an ecosystem that isn't just highly productive, it's intensely customer-focused. We've taken a rigid, painful process and made it beautifully dynamic. As we wrap up today's breakdown, I really want you to internalize this core takeaway. True innovation is building a system flexible enough to move with the wind. Architecting unstoppable agility means finally abandoning those static bottlenecks. Whether they are sitting physically in your server racks or hiding out in your daily team meetings, they have to go. It means letting your ecosystems adapt. You don't build a rigid wall to fight the storm. You engineer a dynamic system that gracefully dances with the changing environment. And that brings us to your final Innovation Catalyst invitation. The Navigator and I want to challenge you right now. Where are your operations currently suffering from static bottlenecks? Look closely at the workflows, the code bases, or the server architectures you manage every single day. How can you apply Principle 15 dynamics to introduce that dynamic flexibility and instant elasticity today? It's time to bridge the gap between abstract ideas and practical execution. Leave your answers in the comments, start the conversation, and let's build an unstoppable culture of innovation together. Thank you so much for joining us in the lab today, and we will see you in the next explainer.